What's up, guys? Cyber Sensei Aaron here, back with day 3 of the TryHackMe Advent 2024. So let's go ahead and dive into that. So first thing we're gonna do is read the backstory here. So late one Christmas evening, the glitch had a feeling, something forgotten as he started at the ceiling. He got up out of bed and decided to check a note on his wall. 2 days in Snowsec. With a click and a type, he got his hotel and tickets and sank off to sleep to the sound of some crickets. Luggage in hand, he had arrived at Frosty Pines. To get to the conference, just follow the signs. Just as he was ready to, the glitch got a fright, an RCE vulnerability on their website. He exploited it quick and made a report, but before he could send, arrived his transport. In the Frosty Pines SOC, they saw an alert. This looked quite bad. They called an expert. The request came from a room, but they couldn't tell which. The logs saved the day. It was the room of the glitch. Boom. So the glitch is back at it. Frosty Pines Resort website had a vulnerability. He exploited it and he was about to send his report over, but his transport got here to go to the conference, and the SOC was alerted on his activity. We're going to learn about the KQL language and how it can be used in ELK, and then we're going to learn about remote code execution vulnerability and how this can be done via insecure file upload. So we're going to actually be doing a little bit of blue team and red team in this task today. So you need to start up your machine. If you're not sure how to do that, you click this machine button. It's gonna be green, and then at the top you click this button, which is gonna say Start Attack Box. I just already have them running because they take a few minutes to start up. So we're gonna go into the operation blue side, which is log analysis and all that good stuff. So ELK is Elasticsearch, so we used that yesterday a little bit, got familiar with it, so we're going to be using it again today. They give us the IP to go to in our attacker box, and this brings us to our Elasticsearch. So what we're going to do, what we did yesterday, we're going to go to Discover, and we're not going to have anything here because we're searching for the last 15 minutes. So here it is. So we click this and we go to Warville Rails, and now that we're there, we need to adjust the time period. So we're looking at October 1st, the day of October 1st 2024. So let's go ahead and get that going. 12 a.m. to 11:30. Boom, update. And we got 811 events here. So let's continue on. Now we're going to add some filters to just make it a little bit easier to understand what's going on here. And here they give us an entry to the KQL language. So for example, if you wanted to pick a specific IP address that you wanted to search, you would put this command in there, and what the quotes do is kind of like saying absolute. So it has, like, the string has to be this or it's not going to show up in the query. And you can see down here they break that down, right? So quotes are for exact searches. Star is a wildcard, which means pretty much anything. So for example, if you wanted to search for like, let's just say you had 10 files, task 1, task 2, task 3, etc. If you wanted a query for the 10 tasks, you would do task asterisk, because anything after task will be picked up by the wildcard, right? Then we have OR, which just is some Boolean logic, and then AND. So and contains both values or contains one or the other. And then that is used for specific field of a document or value. So what we're going to do is make sure we're on the right timeline, which we are. We got the logs, and then we want to filter for this IP address, right? So we'll go ahead and we'll just add it manually for this one. So yeah, client IP, we want it to be is. So is like the quotes. And then it was 10, 13, 27, 115. Yep. Alright, we'll save that. Boom, 422 hits. So now we kind of narrowed it down from 1,000. And then what we're going to do is we want to make sure that it was successful, right? So 404, but here, we'll search it up. So here we go. 404 not found. So it's a client error response, and what it indicates is the server cannot find the requested resource. So essentially, if you try to go to a website and you want to access a specific part or file, if the file doesn't exist on the server, then you'll get this error. So back to this, we want to do, so now they want us to look at the activity of a different IP address. So let's go ahead and change this to that IP. So it was 10.998.239.98.230. Just double check. Cool. Alright, and then yeah, we'll just keep doing the KQL indexes. So okay, response is not 404. Alright, so yeah, you can see that narrowed it down a little bit more. Boom. So using the timeline at the top, you can see a lot of activity from this IP address took place between 11:30 and 11:35. So you can see that here. Well, they actually have that off, so we'll do that too. But yeah, 11:30, you can see where most of this happened. So what we're going to be doing is looking for some more information in these logs. So each one of these logs you can expand here, and it'll give you a little bit of an easier to read format in JSON. You can see right here, this is pretty interesting. So image profile, CSS images, PHP. So yeah, there's they're requesting a bunch of different assets from this website, and then they're getting a response based on that. So here we have 304. Here we have 200, which is a successful get. So let's see here. Looking at the request field, we can see that a file named shell.php has been accessed. So yeah, right here, shell.php. So let's go build a query to find that. Got it. There we go. So we typed in here the KQL line. We're looking for the field message for anywhere that shell.php pops up, right? So we got 11 hits. And you can see it right here. So yeah, shell.php. So okay, so we're getting some responses of 200, which means that he was able to access this file on the server, right? And you can see here before it's a 404, which means it didn't exist. But then now we're getting 200s. So going into what we know about the task, they uploaded the file to the server, and then they requested it again, and they got access, and then they were able to set up the shell. So that's what it's looking like here. And you can see now we've done the blue team side. So to recap, we got an alert for RCE execution. We got the logs, found the event time, which was October 1st, between 11:30 11:35, and then we saw this IP right here, 10.13.27.115, was accessing this file here, which was a shell.php, and you can see right around 11:46 p.m. they weren't able to access this file, right? And then right around 11:53 they were able to access it and successfully gain remote code execution on the server, the web server. So now we're going to look at it from the red team side, right? That's what they want us to do. So here we have RCE and XSS. So we already know what remote code execution is. Here it's saying it's uploading an HTML file that contains XSS code, which will steal a cookie and send it back to the attacker's server. And then they have more background here on the vulnerabilities, what it is, common use of weak credentials, what RC is here, what a web shell is, and here we're going to actually be doing the exploitation. So yeah, RCE is essentially, you can see here, when an attacker finds a way to run their code on a system. And this is very dangerous because now they're issuing commands and they're controlling the server in a way, or the system in a way that is not intended. And this can lead to them gaining persistence, or completely taking over a system and having control over it, which then they can exfil data, they can do pretty much anything if they have the right permissions. A web shell is essentially a shell that is done through web, and specifically it is a script that attackers upload to a vulnerable server, and then they access it like we saw in the logs here. They send a get to that file, and then if it's successful, it'll connect back to a shell they have listening, so that they can now issue commands to the web server. And then through that, they can gain access and persistence to the system that the web shell is executed on, and just causes a lot of problems from there. So let's get into it. So here is a PHP file example of what could be uploaded to exploit the vulnerability. Boom. So this is going to explain what the script does. When accessed, it displays an input field. Whatever is entered in the input field then runs against the underlying OS using the system PHP function, and then the output is displayed to the user. What we're going to do is upload our shell.php file, and normally this is where the vulnerability lies, right? They're not checking for specific file types and then not allowing other types of file types, right? So if we wanted to prevent this vulnerability from happening on this site, what we would do is ensure that only image type files like JPEG, PNG, all that kind of stuff are allowed to be uploaded. Everything else will just be denied and result in an error. And then we can print out an error saying file type not allowed or something like this. But in this case, we're allowed to upload any type of file we want. In this case, we're uploading our shell. It is now successful. And so now we can go ahead and access this, right? So because we uploaded it as a profile picture, it's going to be stored in most likely an image folder, which you can see here. So it's stored in admin, assets, image, and profile. What we can do now is essentially call that shell, that file, which we saw in the logs, by doing it like this, and then boom, we have our web shell going. So you can see here we have the input field and then the execute button. So now we could run any command we kind of want, as long as we have the right permissions. So usually when you gain web shell access like this, you're going to be the user www data, which has some permissions, but you're not root, right? So the whole goal here would then to be, gain persistence. First of all, we want to have an actual shell, and then privilege escalate to root, and then do whatever we're going to do on there. So here are some commands examples that you can run. So you can see you have some Linux commands, and then we have some actual shell commands. So this one would be used to do a reverse shell with bash. This one's a reverse shell with netcat. This one finds the set user ID files with specific privileges, pretty much anything that isn't root. And then here to find files with writable permissions. So this is all stuff you would use to kind of understand what you have access to, what you don't, and begin finding the way you're going to actually get to root user. So what they want us to do is copy this, and then we're going to put it in a text file and call it shell.php. So here's a create file, call it shell.php, open that up, and we gotta put it here, boom, save. It'll automatically save as a PHP file. Yeah, we gotta edit the host file first. So we're gonna copy that, go over here, put this in there, and so this is one way you can do it. This is the fast way, so you don't even have to open the file, you're just appending this to the file. And so if we catted that out, you can see it's right here. So sweet, we've added it to the file here. Now we'll go back and we're gonna go here. Oh, might have opened it in the clipboard, but anyways, put that there, paste and go, and boom, we see a very nice Frosty Pines Resort website. Alright, so once we've booted up the website, now we need to log in. You can see here we have a couple different logins that most people will try to gain access. So we're gonna try this one, and it has a password of admin. So let's go log in, then admin at, and it says domain name, so This is the domain right here. So it's gonna be frostypines.thm, and then the password was admin. Boom. So we've logged in now as admin at frostypines.thm. Definitely got to change that. It seems like they left their default configurations open. So now what we got to do is find our point where we're going to exploit, right? So here we are in the dashboard. Looks like we can see the rooms. We can add a new room, reservations, users. So let's just add a new room. And you can see here, room image. So let's go ahead and select that. Then we're going to do all files here, and we're going to select our shell. So let's see if that works. So it's going to be room 202. We got to remember that. So all right, so we can see here we got our room 202. It's been added, and our shell is this little white space. It's not an image, so it won't be displayed. So now we have to find the location, right? So what we can do here is inspect the page source, go to network, and then we're just going to refresh. And what this does is this section right here is going to capture all the requests that are being sent by the page, and because it's not an HTTPS site, we're going to be able to see all the traffic in plain text. So let's go ahead and reload the page. Boom, you can see we got a whole bunch of HTTP requests here, and now what we have to do is find the one we're looking for. So we can just go here, and you can see we found it. So let's click on that. Boom, we have our URL, right? And you can remember they gave us the URL here. So where is it? Right here. But in a real scenario, you wouldn't have it. Like, no one would tell you where it's at, right? You would have to figure that out on your own. And so this is the method we're using for this site specifically, depending on what you're doing and the site you're on. Most sites nowadays are HTTPS by default, so this might not work. But for this specific instance, we can do this, and they give us the exact location. So we'll go ahead and copy that. And then all we're gonna do is navigate to that link and see if we get the code. Boom. So we now have a web shell on frostypines.thm. This is what Glitch was doing before he took off for his conference. So now what we have to do is find the flag.txt file, because that's one of the questions they ask you. They ask you what's in there. So this is called a foothold, right? If you're going through the penetration tester methodology, this is called a foothold. So foothold is after initial exploitation of the vulnerability that you found, and now you're kind of just a user, or just a base level privileges, whatever privileges you have, whatever user you log in as. There's a way to find that out, and we'll do that here. But right now, it's a foothold because we are in the system, but we don't have persistence, right? And we don't have high privileges. So the goal here, if you were an attacker, would be to gain persistence and then escalate privileges. Doesn't have to be in that order. You could escalate privileges and then do persistence, because in order to write to different areas of Linux, for example, or Windows, you need a certain level of permissions. So typically people will escalate first and then do the persistence. Well, let's carry on. So first things first, we got to see where we're even at in the system. So we're going to do an ls. We can see flag.txt. They were nice and they just put it in this directory as well. But we're going to do pwd. So if you recall, print working directory is going to show us the directory we're actually in. So you can see we're in var www html public media images rooms, and if that seems familiar, there you have it. So let's go back here, see some other commands that we can run just to see how far we can go with this. So we got who am I, so that's going to be the command that you're probably going to want to run first, because that's going to tell you what privileges you have. And we're www data, so we basically have the same privileges as the web server, right? So we can find out the host name, so what's the name of the computer we're in. We can find out, move this down a bit, we can run this, which will give us some information on the operating system, kernel version, and more. And this is helpful information for escalating privileges, right? Because depending on the OS version, the kernel version, and we'll just run it just to see. But depending on that information, we can use that in a Google search and search for vulnerabilities. So you can see here we're on Linux. This is the version. It has an AWS, Ubuntu, and then here we have some extra information. So what we can do, like if we wanted to escalate privileges, we can just take this whole line, put it in Google, search vulnerabilities, and we might come across something that could help us. But in this case, we're just going to keep going. So we can see the network, we can see if the user is assigned to any groups. Let's go ahead and look at that. So yeah, it's the pretty standard groups. So wait, that's pretty interesting. Let's see. Yeah, so I thought we had sudo privileges, but we don't. But anyways, let's just continue on. So flat dot text, we want to cat that out, and we get the flag. So glitch was here. He left a fingerprint for us. If you're a hacker, you probably don't want to do that, because then it kind of just points to you. So no, that's not what I wanted to copy. Hold on. Boom. And paste and submit. And there you have it. So this task was pretty cool. We got a little bit of red team and blue team experience. So in the first part of this, we did our Elasticsearch SIM analysis of the logs. We saw what it looks like from a defender's perspective, and then they gave us a little walkthrough on how it would look from the attacker's perspective. That was a pretty cool task. They had 2 on log analysis, and I mean, these are pretty important because if you're working in a SOC, if you're a cyber blue team defender, it's important to understand how to identify attacks and what red flags to look for, what signatures to look for, in order to be able to effectively, look for attacks and determine true positive or false positive. But if you guys enjoyed, leave a like, comment, subscribe, and I'll see you for day 4. Peace.